All right, we're good.
Okay. Hey everybody, I'm Eric Sorensen. I'm the organizer of MadJS. Thanks for coming. So we want to say thanks to Earthling Interactive for the pizza. And for the talk tonight. And we want to say thanks to Hani for recording all of our talks and posting them to YouTube. If you haven't gone out to YouTube and looked yet, I think we're almost up at a year of full catalog. So that's awesome. Thanks, Hani. You can check out our online shirt store at screen.com/madjs. There are shirts just like this one, all different colors and styles. So those are all out there. And you can find out all this information at the madjavascript.com site. We have our contact info, schedule, sponsor links, all the videos automatically pop up there, and we have our code of conduct there as well. Do we have any announcements?
I have 2 JavaScript application positions open, so if anyone is interested in looking to do JavaScript application, let me know.
Hi everyone, I'm with American Family Insurance. We have probably about 20 different positions open around JavaScript, mobile development, native, mobile web, pretty much runs the gamut. We're going to have a job fair coming up at the end of the month at American Family. But in the meantime, the posters are all out there. If you have any questions, please let me know. Thanks.
I'm Nick. I work in Mobile Igniter. We're looking to hire around 2 devs. Do mostly JavaScript and hybrid mobile. We're working in the Internet of Things space. It's exciting. It's downtown. You need to be able to walk here from there. So talk to me afterwards. Otherwise, I'm Nick at mobileigniter.com.
Josh Thomas, I'm a developer at Earthling Interactive. I'm actually giving the presentation tonight, so I'll be up there in a few. But we have positions, openings at Earthling Interactive, so if you're here to hear about React and you want to do React development, then hit me up after the presentation and talk.
I'm William Conrad. I'm with Restore Health, and we have 2 contract openings right now, 5 a 6-month duration. And so likewise, if you're interested in so we have
Any others? All right. Well, that's it for me. I'm going to plug your laptop in there.
Good. All right. Like I said before, I'm Josh Thomas. I'm a developer at Earthling Interactive. If you want to learn more about me or follow me, my handle is jtoms1 at Twitter or on GitHub. And I'm here today to talk about React. Has anyone here used React before? Okay, so this might be boring for you. We'll see. So what is React? React is a view rendering and user interaction library. It's typically called the V and MVC. It's created and maintained by Facebook, and it was created back in 2013. So when React first came up, I actually dismissed it. Did anyone else do the same thing? Like, I'm putting XML in my JavaScript. I'm not going to do that. That just seems crazy. And they also couple their views and their controllers very tightly together, which, you know, coming from a typical MVC background, that seems very wrong to me. Until I went to a conference last year. I went to Nodevember, which is a Node conference. And there was a lot of buzz in the audience from attendees talking about how they use React on the server side. And I thought, that's crazy. Like, I can use the same view code on my client and my server and it just works. That, it sounded pretty amazing. But that's really what prompted me to learn React. And really, that's just kind of the tip of the iceberg. And some of the seemingly odd decisions they made in developing React actually turn out to produce some pretty amazing results. So why would you use React? Number one, and always most important, is the simplicity of the framework and working with it. So React applications are composed entirely of this concept of components and nothing else. So a component is a JavaScript object that represents a portion of the user interface. So that could be a header, a footer, main section, multiple items. And it encourages a modular architecture. Also, React has a very tiny API that is completely around the life cycle of components. So you're kind of getting the trend, right? Everything is about components in React. It also has reactive updates, which is where React gets its name. This is where you declare how you want your application to appear at any point in time using a state object. And then React updates the views based on that. The other benefit of React is its speed. And it's very fast, and I'm willing to say it's probably faster than most frameworks you've worked with, Angular included. I'm not to say about the speed of Angular 2.0 because I haven't used it, but I understand it's very fast as well. Now this speed comes because React does a little bit of magic, right? So it controls the rendering of the user interface. You're just defining it how you want it to appear, and React does all the updates for you, doing deltas in a virtual DOM, which I'll talk more about later. So what exactly is a React component? Well, it's a view and a controller merged into one. So all templates and all interactions of your application are handled by React. So there's no bindings, there's no view models, there's no scopes. The scope of a component is itself. And applications are created through a composition of multiple components. So you'll have a component sitting at the top of your application, right? And then, and that's going to attach to a DOM node. And that single component is going to have children. And they're going to have children, and children, and children, until you have this tree structure. Each component is also thought of as a state machine. So each component maintains its own state. So if you're thinking about it in a UI, you're defining how does my app appear in the various states that could occur. And then you're letting React adaptively change and react to your state changes within the user interface. React also has this concept of props, which I would just call these like named parameters. It's a way of passing values from your parent to your child. Now that value could be a function, it could be an object, it could be a string, it could be a number, it could be any number of things. But remember, when you're working with components and you have this tree structure, your data flows from a top down. So if you're controlling state in the top of your application and all your data resides there, you'll push that down through the application to all the child components. So here's an example of a stateful component. And this is like the simplest example that I could come up with. So these are both lifecycle functions. The first one being getInitialState, which is the first method that is called on a React component. And in this case, I'm setting the state to name Josh. So state is always a key value object like this. So when it's mounted and rendered, it's going to create a div that says, hello, Josh. Pretty straightforward, right? Does anyone have questions about this? All right. So if I were to ever change state on this component, it would immediately re-render. So changing state on a component causes it to re-render. Remember that. So we also have this other concept of a pure component within React. And a pure component has no state. Its state is truly defined by its parents. So in the second component here I have defined that's called hello. Notice that it has no getInitialState. And it's dependent upon the properties that are passed to it from its parent. In my hello container is where I'm providing the state. And when I'm rendering, I'm including this XML that says, really at this point in time, I want this component to appear, and pass this property to it and call it name. So changing, I said before, changing state on a component will cause it to re-render. It will also cause all of its children to re-render as well. So if you have this component that's handling state at the top of your application, and you change state at any point in time, it trickles down, and your entire application could re-render. Yeah?
Return values, are those somehow magically interpreted, or are those supposed to be quoted? The return hello magically interpreted.
The XML.
Where
Yeah.
the return did, for example.
Magic. So I kind of said this before, you're pushing state to the top for simplicity, so you only handle state management in one location. The rest of your application or a component of your application can just listen to that. So you're going to re-render all the time, and you're not going to worry about it because the performance won't take a hit. Right? So how does that happen? Like that's not something I would typically think about when I'm working in an application. Like I always want to worry about how fast it's going to be. Now, typically in the past I would have handled state management a little bit differently, like if I'm working in a backbone application. Because I'm always worried, is this going to re-render? Is this going to re-render if I change this? Well, that's where we get to the magic of React. It's this concept of a virtual DOM. So it's performant rendering through patch updates. So the first time you render a component, it saves a copy, right? I know what this component looks like at this point in time. If I do it again and change something and it re-renders, I have a second copy. Now I can compare the stored copy to the new copy and identify the deltas. And when those deltas occur, it does targeted surgical updates to the DOM instead of destroying everything. So when you're updating this, and you need to understand how the virtual DOM actually works. It's because it's magic. So as a developer, you should not worry about how it works. It is what I would say the right kind of magic, because it always works. But what's it actually doing? Well, it's doing dirty checking on the DOM virtually. So this is an example of two renders. The first render is A and the second render is B. Can everyone see this okay? No problems? So when I change state from the first to the second render, what I'm actually expecting is that the ID now changes from the word before to after. Now React learns that, looks at it, identifies the differences, and this is actually what it's going to do. It's going to replace the attribute ID with after. So you're not blowing away this DOM node. This is the same DOM node that was there before. React is just updating it. So what if I render one time, make a change to state, it renders again, and identifies that they're the same? React says, great, I don't have to do any work. Things get faster. In this last scenario, re-render, second item to the list. React identifies the variation and inserts a DOM node. Straightforward, simple deltas, and targeted updates. So if I have this React application I've built and I want it to, start up in my page, how do I do that? Well, this is the startup code for React. I identify one component. I identify one DOM node. That's it. Attach this component to that DOM node, and then let your application kick off. Pretty straightforward, pretty easy to do. That means you can also have multiple React applications running at one point in time. So there has been one question about this, and it's, what is this magic, right? Why is there XML in my JavaScript? And now, the first time I saw this, I'm like, that's an error. Why didn't someone quote that? Right? That's not valid JavaScript. And it's not valid JavaScript. And that's where we come into JSX. Has anyone heard of JSX beyond the React developers? Was it in hatred about what kind of magic this is? So this is the component I showed earlier, the hello component, where we're including a bit of JSX and it's used from another component, right? I'm including the hello component in my hello container. So what do you think this gets converted to by a preprocessor? What's the end result?
XML. The DOM fragment.
Function calls. So I would have expected, well, you know, it's going to look at hello, identify what HTML sits in hello, and then, you know, generate that. But it's actually just making function calls. So when you actually see, if this were a div, it would do the same thing, and hello would be replaced with a string that said div. So what you're seeing is that React is abstracting away the creation of the HTML even more. So we have the virtual DOM that does the comparisons for us, and then we have this abstraction of JSX, where I'm never actually writing HTML in my React applications. In React, when it's pre-processing, it's not creating HTML either. That's all done on the fly by this library that they maintain. So, yeah, React needs a preprocessor. Does anyone here work with preprocessors right now or build scripts? Grunt, gulp, any? So, most people. That's kind of what I expected in 2015. Okay, so one example of a preprocessor you could use is Webpack. Webpack is not very common, but it's really popular among the React crowd. So if you're looking at a code example online, they'll probably talk about Webpack if it's React-based. I'm using it for the demo. It's pretty cool, but it's pretty new as well. I think it got popular because Pete Hunt, one of the developers at Facebook, talked about it in a presentation. Everyone's like, oh, I'll use this instead. You can also use Browserify. Does anyone use Browserify? If you're working with common JS modules, you're probably using Browserify. It's really good, and it's really easy to drop in different types of transforms. So in this case, working with React, we would have Browserify with a Reactify transform that converts the JSX for us. You can also use Babel if you feel like living on the edge. So Eric actually talked about Babel last month. And this is kind of the go-to preprocessor for ECMAScript 6 code to convert down to ECMAScript 5. And it supports JSX out of the box. So you don't have to do anything. You can write, you know, your ES6 code with JSX. All right, now I'm going to jump into some code. So this is the repository for this presentation and the code I'm about to show. If you have laptops and want to look at it, good. Yeah, I'm sorry. I'm going to show you a to-do MVC app. So is everyone familiar with this? Right, I'm adding, it's just a to-do list. Right now this one's actually running in memory. So I can add new items to it. I can edit existing items. I can set items as complete, delete items. Right, pretty straightforward. So I've modified the code a bit to show how React works and how the life cycle happens, so we can see the order of it. So, okay. So I have a container around this entire application. Actually, you know what? Let me just show you what it looks like. So Facebook created this nice set of tools for Chrome. I think, is anyone, any Angular devs? I think Angular has something similar to this. It's pretty nice. You can see the structure of my application. Here's my to-do app component. Here are its children. I've got a header, main section, footer. And then my main section has a list of items, which is another component. So when I change anything within the state of the application, I will say the state of this application is held at the to-do app level. So the very top of my application is where I currently have state. That's where all of my to-dos are. They're all listed there. So if I were to change anything that affects that list of to-dos, it's going to start re-rendering. So it re-renders the to-do app, which has a header. The header has a to-do text input. Can everyone see this, or is it too small? Better? Yeah, I assumed. Thanks. So you can see it went down the tree, rendered the main section, rendered the multiple to-do items, and then rendered the footer. So what would happen if I were to change the number of items in this list? All right, so when the page loads, I'm going to have 1,000 to-do items. So it takes a little bit, but it's, you notice it's spitting a lot of stuff out to the console log, which takes a while. So here's all my items. I'm going to scroll down, but there's 1,000. So what do you think is going to happen when I say this one item is complete and it updates state at the top? It just re-rendered everything on this page virtually and did a comparison. So you see when I click this green check mark, it's kind of slow. But let me close this console. And that's really not too bad considering it's rendering. Let's see. You know, close to 5,000 DOM nodes. So that's all well and good. Now, what if I have 10,000 or 100,000, which seems just ridiculous. We design our apps so we wouldn't run into this scenario. But what if I did? And I go through the same setup, and when I set something to complete, the user has to wait forever. Because I updated state and my entire application is now re-rendering itself. Well, React has a way to solve that. So I'm going directly to the to-do item because I know that's the one that we're like looping over 1,000 times. So there's a lifecycle function called should component update. So if I have this pure function, which is a component, and I'm passing properties into it, and it's maintaining its own state, and it only re-renders when it needs to be changed, we know the inputs to that function, and we know what the output should be. What happens if the inputs don't change from one call to the next? What I'm introducing here is a memoization, right? I know that the next time I call this, I'm going to check. Well, are the parameters the same? If they're the same, then I don't need to do any work. But if they're not the same, then I'll allow React to do the virtual DOM diffs for me. So let's go back and try this in the browser. So it's still doing all the same work. It's just that now I have this way of saying, has anything changed? If it hasn't changed, don't do the virtual DOM work. So I'm okay with this performance. I mean, it's, right, that's pretty fast. Now what happens if I set them all to complete? Yeah, we're gonna wait a little bit longer for it. So I guess I should show a little bit more code here. So this is what my HTML looks like when it first loads up. I have a section with an ID of to-do app. Here's the first bit of JavaScript code that gets ran. I'm saying let's load up this to-do app component and let's attach it to that location. You see my to-do app component is requiring a header and a footer and a main section, and then just plugging those in to the JSX code. And you can see that I'm passing properties down. Yeah?
So I noticed the file extension for this file is .js, but there's JSX in it?
No longer required.
Really?
Yeah. I don't remember what version that is, but you don't even have to put the JSX program at the top anymore.
Oh, cool.
Yeah.
Is there a way to use some templating instead of having all your rendering right in JavaScript?
No.
It's the controller in view.
It's the controller in view. So I would ask then, why would you want to do that?
Well,
Coming from a background, I would have agreed, but
you know, when you have UI people, say, development people, you kind of separate the concerns, maybe.
Sure.
Focus on just the UI, just the interaction.
So if you're working with an Angular app, there really isn't a strict separation ever, right? Because your Angular app has all of this code in your HTML to define how it will interact with your controller. In Backbone, we kind of did a similar thing. So that's why they made the decision that why is your view and controller separated? Like, you're probably working on those two pieces of code at the same time anyway. So why not just put them together? And I think that's why they made the decision.
I think they're arguing that they're not separate concerns.
Right.
They're actually the same.
Now, the bit you had on like having a designer or someone else create the HTML, that's probably a valid concern. And I don't know what the answer would be for that.
So how would you work on a project like this with a designer? Well, you don't.
It'd be pretty easy.
Have them give you the HTML. Or you could just have them start, I mean, if you're comfortable enough with taking the HTML from the designer you work with, having them just start creating components instead. I mean, you don't have to have all of this code, right? You could just have a return with the code at the bottom, right? Just the JSX. So it would, if you have a talented designer that could do that, it would be pretty easy to get them to start writing JSX.
Is it true that you really only need to write the rendering code for the stuff that you want to react to input? Or, I mean, you have the HTML file there somewhere that
Oh.
out some stuff, right?
No, I mean, yeah. Well, yeah, but there's not much in that. I mean, you're going to have... So your question, like, I've got to serve something, right? I've got to serve an HTML file to start with. Now, I could render...
Like, you kind of made it the top of your whole app, right? I'm thinking, well, could I just make smaller parts of my app into these React things and maybe have a handful of them on a page? Instead of
Yeah,
going to the top?
yeah. I see what you're saying. Yeah, you could probably do that.
So that would require as much
but then you might run into an issue, right? So the reason that I have it done this way is I have this one component that sits at the top, and it's got a couple children that are, and the children are responsible for different UI portions of the app. But that top component is also, it contains the state, and it understands whenever a piece of data changes. And then it can tell its children, like, okay, react to the change that I just made. Now, if you break them into separate applications and locations on the page, you wouldn't get that coupling in the data flow.
But there would be cases where you wouldn't have connected things. Still,
Yeah,
kind of
no,
leverage React for
I agree.
Yeah, I don't know if you're going to talk about this, but where I've used it is in taking pieces of an Angular app that really didn't need to be rendered every time the scope changed, and do those with React
Yeah,
inside of the Angular.
It's my last slide.
Okay.
Yeah, I will talk a little bit about it.
Can you show footer and header with JS?
Yeah, no problem.
Out of curiosity.
So here's my footer. Right, so this only has, it has prop types and it has render. Which prop types is kind of handy if you're using properties or you're using components that someone else has created, because I'm identifying within this component that the all to-dos property that is passed to me needs to be of type object, and it's required. So I can't actually include this component in some other JSX without meeting those needs. So it throws an error during development. We wanted to see header, right? So here's the header. One thing interesting about the header here is that I'm including a component called to do text input, and I'm passing a property to onSave, which is actually a function within this component. So now anytime I reuse that text input, I just pass a function to it to tell it what to do when it saves it, when it wants to save. So why would I do that within this application? Well, for the input that appears at the top, that's a new to-do. But now if I'm modifying one of these, it's an update. That's why.
Can you show the to text input?
Sure.
So where does that emit that? It's unsafe. How do you bring up those events?
I'm just calling this.props.onSave. Passing it the state, the value of the current input, and just provides up the chain.
So onSave, you just make anything.
Yeah, I could call it any word. It doesn't matter. It's nothing magical. But then the save function is called from onBlur. And this is one thing that React does very nicely, is that it has its own event system. It's a custom event system. And you don't ever depend on the browser you're using what their event is, because React handles most of it for you.
Does it handle mobile events very well too, like swipe left or swipe right?
Touch events. I can show the complete list. By Googling React events. Clipboard events, keyboard events, focus, form, mouse. No swipe events.
Did you say no swipe?
No.
Not touch move.
There's on-touch start, I think, and on-touch end. On-touch move. Is that usually used?
I'm sure someone wrote something.
Either is
Yeah, you can do it yourself. Right, there are some nice helper libraries available. One is Immutable.js, which is actually what I'm using within this application, the to-do list. Immutable.js is a way of creating immutable JavaScript objects and arrays. So why would we need that? Well, there are a few things in JavaScript that are immutable. Strings, numbers, can't think of anything else, but arrays and objects specifically, you can mutate them. So what I showed earlier with the should component update, actually I think I've got a good example of this. So what's in A? Stuff. Because you're just pointing to it. So if I compare A to B right now, yeah, they're equal. Well, it's the exact same object. So in JavaScript, whenever you do something like this, you're just looking at the location in memory. With immutable, if I were to change this code, here's an example. It's a list. If I do a push onto the list, it returns a new list. You can't actually mutate the to-do list.
Is it an entirely new list or just partially new list?
Good question. It's in, yeah.
Okay, so it doesn't share any of the same.
It actually does behind the scenes.
Does it?
Immutable.js does
So it's
interact.
There's an excellent presentation on Immutable.js on YouTube. I think it was done at ReactConf in January. And it's kind of mind-blowing the way it works. But for me, it's just, I can't mutate it. So I know that anytime I use it in a component should update, it's always going to work. React router. So React doesn't have a router out of the box, but React router is actually pretty awesome. A lot of community support behind it. It's completely based off of Ember's router. So someone looked at Ember's router and said, I'm going to make that in React, and here it is. And it actually looks like JSX code. So here's an example of what defining your routes looks like. Yeah.
XML configuration.
Yeah. Not. I know you're thinking of Java right now, but don't. It really is great, I swear.
You can also do it in JavaScript then.
You can, yeah. Yeah, because this just equates out to functions.
Yeah.
Yep. Yeah, you don't have to write JSX. You can just write it as function calls. When I worked with React Router the first time, I immediately thought of Angular's UI router. To me, it felt very similar, and that's a good thing. And the other helper library I want to talk about is Flux. So Flux isn't really a library, it's a pattern. It's a way of working with data within React using a one-way data flow system. So this is kind of an example of how it works. A view would call an action through the dispatcher to update a store. Flux is complicated. And anyone working with React and Earthling Interactive would probably tell me that it's very complicated. We're using it on a few applications right now. If you're planning on building a large application, it's great. If you're not working on a large application, don't try to embrace it because there's a lot of boilerplate that comes with it. But it is very good at creating a highly decoupled environment. So rendering abstraction for the win. So notice that we never wrote HTML. It never rendered HTML until it got to this outside library. And it's doing this craziness with like the virtual DOM diffs for us. So that's got some great benefits. You get to do server-side rendering, okay? So you can take one of those components that you already have, call it from a function in Node on the server, pass a couple properties to it. It'll go through, create a virtual DOM, convert it to a string, and we'll return the string to you. So it's kind of magical the way it works, but when you really think about all the abstractions that go into how React functions, it's not really that complicated.
Why would you want that over client-side rendering?
So there's a debate on this. It's an isomorphic application then, and the first bit of code that is delivered to, or the first bit of user interface that is delivered to the person viewing the page, it's immediate, right? You're not waiting for any JavaScript to download. So if you render it server-side, you know how I showed I'm delivering this index.html file that really has nothing in it right now, and then it's loading up the JavaScript and then changing the page. Now, imagine that over 3G.
Sure, we can preload your components.
Right, but you're still waiting for all the JavaScript to come down for it.
There's also SEO.
Yeah, and there's also, SEO as well.
And clients that don't run JavaScript.
I'm sorry?
Clients that don't run JavaScript.
Yeah, and clients that don't run JavaScript. But what's really cool about that is that the same bit of code, the component that you created at server-side, you can then load it client-side, right? And it looks at the code and it does checksums and says, oh, well, the code that I would create is the code that already exists here, so I don't need to update it. So it just will immediately take over.
So you get a faster initial load.
A lot faster, yeah.
Which is a major problem. Big thing.
Yep. There's a library, React Art. It's a way of working within,
Sorry, for the server-side rendering. Does that also make it play pretty nicely with something like Atom Shell or like some of the other things where you can take like a Node.js backend and turn it into an application, like a standalone application?
It's a little different, right? So Atom actually uses React right now. So if you're using the Atom editor from GitHub, that user interface is done in React.
I think we're using, you're using Vim now.
Vim. I don't know. I used VI a long time ago, and then I really kind of missed it and decided to go back to it. Vim has a plugin for everything you could possibly need. React Art, working with SVGs. So you can build components the same way you always did, and you're actually creating SVG instead of HTML. You're still writing JSX, though. And then there's React Native. I really wanted to show some code for React Native, but knowing how much time it took just to cover the basics of this, I didn't get time to do that. But React Native is a way of creating React components for iOS, and possibly for Android in the future, I think a couple months away. So you're still creating components, you're still writing JSX. It's a similar workflow, but what gets created isn't HTML, it's native iOS components. There is no web view here. This is actually just generating native code or native views. This got really popular when it was first shown at React Conference in January, and then Facebook didn't release it. And I think they released it like 3 weeks ago, and there's been a lot of cool stuff that people have built from it already. So you're seeing a lot of components come out that are going to make it really easy for you just to spin up a new application using the pre-existing components that people have contributed to the community. Maybe I should give a presentation on this in the future. I'm pretty excited about it.
Is that just iOS stuff?
right now. They are saying like 3 to 4 months in the future they're going to release it for Android. And that's one of the nice things about when Facebook open sources something. So when they open source React, they didn't build it for the community. They built it for themselves. And they created Instagram.com, I believe, is a completely React application right now. And then they decided to open source it. So they're dogfooding all of this work. So you can download applications right now from Facebook that are built in React Native. It's a cool idea. One of the other things about React, greenfield, not needed. You don't have to be starting a new application in order to use React. You can use React with Angular. You can use React with Ember. You can use React with Backbone, Vanilla.js, or, you know, if you've got greenfield, that's great. You can use React out of that. So what I'm trying to say is there really is no reason for you not to use React today. Just go home and if you hate JSX, I understand, right? It's really weird. But give it a couple hours. Try it and just see how it feels to develop with React and JSX and these components. And you'll have a different attitude, because I know that I had a different attitude when I worked with it for a while. That's it.
How does it support testing?
Testing?
Yeah.
Well,
shouldn't have asked.
So they created something called Gist, which is based on Jasmine, which is a unit testing framework that you can use with React. But, right, these are pure. So if you're passing options into it, or you're passing properties to it, and you can set the state, you know what the expectation of the result is, right?
Yeah, that's not the point.
So it's pretty easy to test these components. Now, to say, have I done it? No, I haven't done it. I should be doing it, but I haven't. So these are some links. Here's a link to React. This is a site that has all the different components that are available to you if you're working in React Native or React for Web. You can search.
Is there a date picker in there?
Oh, yeah. See, it's funny that you asked that, because about 2 hours before the presentation tonight, we were looking up a date picker. So there's a couple.
I can say that.
And guess what? They're not based on jQuery behind the scenes.
I don't believe you.
Guaranteed,
In
right?
defense of Angular, I mean, you can wrap your directive around jQuery date picker. You get yourself an Angular date picker.
I know. It's more complicated than that sometimes.
And that's something I haven't noticed with these, right? You can use jQuery with React. You create this concept of portal where you say, I have a component that's responsible for this location in the DOM, and then I'm never going to update myself. I'll let jQuery have this DOM node and do whatever magic they want to do with it. I wish I didn't say that, and I wish that wasn't available, but it is. But you're far less likely to find components built with jQuery behind the scenes. And I know that when I worked with Angular, that was pretty common.
Yeah.
And I think that's partially because people don't feel bad about that, right? Because you're replacing jQuery or JQLite or whatever it's called with jQuery anyway. So what's the hit?
Well, the weight of the library is the hit. It's huge.
And that's another thing. React really isn't that large of a library. If you want to replace jQuery with React in your application, it's actually smaller.
It's smaller than jQuery?
I believe so. Yeah. All right, we're going to look it up.
So it gets sent to the browser, just the rendering library. So you don't have all the JSX conversion stuff.
Oh, yeah.
Yeah, you're going to do all that with the preprocessor.
Doesn't actually do very much.
That's good, right? Yeah.
Oh gosh.
Count the characters.
And you see that on that.
Dope. So that is non-gzipped. It's not bad. Any other questions? Anything I didn't cover? Questions you might have? If you want to look at the code again, I can show that. All right. Thank you.
Thanks for coming. Next month will be in Europe. New York? Oh, yeah.
So wait, by default, so it always does the dirty checking. And that's in the virtual DOM? Okay. But then it doesn't, and it will re-render the entire virtual DOM if you don't tell it not to. Of that component. Okay. And it just so happened that component had a lot of children. Yeah.
The concept that I'm pushing, the state already probably isn't something you're going to do in most applications anymore, actually. But you can do that if you want to, as long as you're using the ship component up there.
Okay, so wherever the state resides is where you start. Okay.
Any place with a state, remember, you can't really render yourself.
Right.
You have to do a state change.
Right. Reminds me a lot of, I was thinking of closure script. We started talking about...
Okay, so I was actually about to say that closure script is a library called O. That's optimized.
Oh, yeah. Okay.
And now they've done performance measures on Chrome is actually faster. Now the reason for that is that wicked fast closure script is all immutable.
Right.
So you don't need to use something that immutable to rest.
Are you closure script? I want to. No, I want to. Really bad.
I thought I did. It's really bad.
No.
I have to get past the fact that it's this. It's not pretty.
A few days.